Hi everybody, today's lesson in geometry is lesson 2.6, talking about special angles that occur on parallel lines. Our objectives today are listed at the top of your notes. We're going to be able to understand the relationship between special angles that are formed when we cut through parallel lines. And then we're going to use deductive reasoning, that explanation or logical reasoning, to prove our conjectures. Okay, now we're going to be using this diagram up at the top right, and we're going to list out as a review all of our linear pairs and vertical angles. And this is from the last lesson that we covered. So let me zoom out a little bit so I can get all of them on one page. Okay, now remember, linear pairs, those form a straight line. They are next to each other, those two angles, they share a side and they share a vertex. And I did that little cheat method of being able to draw that protractor type shape. So over this 1 and 2, it makes a nice protractor. And so angles 1 and 2 would be a linear pair. Okay, now I could do that again. 2 is also next to angle 4, forming that straight line or that half circle protractor shape. So 2 and 4 are also linear pairs. So take a minute, try to find the remaining linear pairs, and then check your answer. All right, I'm going to fill in the rest of the linear pairs here. Now, the order that you put them in, 1 and 2 versus 2 and 1, that doesn't matter. How you have them ordered in your blanks here, it doesn't matter as long as you have the same pairs. So another pair would be 3 and 4, 1 and 3, 5 and 6, 8 and 6, 7 and 8, 5 and 7. So those are all of our linear pairs. And remember, together those linear pairs, each pair adds up to 180 degrees. Okay, for our next one, we're going to be doing vertical angles. And remember, vertical angles share a vertex, but they do not share a side. And those angles are the same size. So visually, this is kind of easy to figure out because here you can see angle 1 is an obtuse angle, whereas angle 2 is an acute angle. So those couldn't be vertical angles because they're not the same size. So remember, vertical angles share a corner, but they do not share a side. So an example would be angle 1 and 4. All right, now take a minute and try to find the remaining 3 vertical angle pairs. All right, let's check your work. So the remaining pairs would be 2 and 3, 5 and 8, 6 and 7. Okay, now that picture up above was showing 2 lines that were getting sliced by another line. And that other line is called a transversal. And a transversal's definition is a line that intersects 2 or more lines. And these lines could be parallel, but they don't have to be. Okay, so up here I'm going to show it on our picture that this line right here, that is our transversal. Okay, now these two lines do look like they're both horizontal and they're both parallel, but because there's no arrow markings, we cannot determine that. So in order to show that they were parallel, we would have to have arrow markings on there. All right, now because of this transversal, it's creating a special connection between some of the pairs of angles. So I'm going to do 2 pages at once, or not. Looks like we'll just have to steal the picture here. Okay, I figured out the glitch here. All right, so on the right-hand side, we are going to be looking at those special angles, and they're going to be matched up and named. So these angles here, the example that we have for angle 1 and 5, just grab a pen. So angle 1 and 5, if I highlight those, we can see those here. And here. And those are called corresponding angles. And that's because they're in the same position where the line that's horizontal is getting cut by the transversal. They're both in that upper left-hand corner. So over here it says corresponding angles are 1 and 5. What other pairs of angles have that same relationship? So if I were to put down angle 2, what angle would be in the same position as angle 2? And that would be angle 6. So here I could mark it on this side, angle 2 and angle 6. All right, what about the next two pairs of corresponding angles? 3 and 7 would be a pair of corresponding angles. 4 and 8 would be a pair of corresponding angles. Great. All right, the next one we're going to look at is alternate interior angles. And alternate interior angles are the ones that are inside the two horizontal lines, but they're on opposite sides of the transversal. So here if I'm looking at 3 and 6, 3 and 6 over here are these two corners. So what would be another pair of alternate interior angles? 4 and 5. Next up is alternate exterior angles. And exterior means that they're on the outside of those two lines. But again, alternate means they're on opposite sides of the transversal. So if I'm looking at 2 and 7, what would be another example of alternate exterior angles? 1 and 8. Okay, now again, these two lines look like they're parallel, but they're not marked to be so I don't have enough data. But when they are parallel, these specific pairs of angles have special connections, and we're going to talk about those connections. All right. Now in this diagram, we have that transversal that's slicing through, but we have two parallel lines. So right here, we can see that those arrows mean the lines are in fact parallel. If we merge these lines together, where I squeeze them so that they come together on top of each other, what would we observe? So I'm just going to use my highlighter to show you what it would look like if I were to squeeze those together. I'm going to trace over these portions of the line, 1, 2, 3, 4. And then I'm going to take my pen and I'm going to grab all of that information there. Let's make it group together so it'll all, oops, it was already grouped. All right, so I'm going to take that piece of information and I'm going to slide it down so that it matches up with that next horizontal parallel line. And what do we observe? Well, I can see that angles 1 and 5 match up, 2 and 6 match up, 4 and 8 match up, 3 and 7 match up. So there we have the angles that slide down onto each other. They end up overlapping and being the same size. Now remember, that's the symbol for congruent. So when this happens, These are corresponding angles. 1 and 5 are corresponding, 2 and 6, 4 and 8, 3 and 7. So that means corresponding angles on parallel lines are congruent or equal. Okay, now if we look again, alternate interior angles. Those were the ones that were inside the parallel lines, but on opposite sides of the transversal. So an example would be 4 and 5. Now when we slid number 4 down, it landed here. And 4, being in this position, is now a vertical angle with angle 5, which means they are equal in size as well. So alternate interior angles are also congruent. And then when we're looking at alternate exterior angles, that was like 2 and 7. So if I slide those angles down again, angle 2 landed here. 2 and 7 in this position are now vertical angles, which means alternate exterior angles are also congruent. So what they do in math is they like to condense things as much as possible, and they're going to take all 3 of those sentences and put them into one statement. So it says, if you have 2 parallel lines and you slice through them, then all of those special angles are congruent. So I'm going to mark that on this picture here. So corresponding angles, that would be like 1 is equal to 5, 2 is equal to 6, 3 and 7 are the same, and 4 and 8 are the same. But because we have some vertical angles going here, I also know that 1 is equal to 4. So now that I have that mark for 4, its corresponding angle is also the same, which is angle 8. And same with angle 3, it is a vertical angle with number 2, so they are equal. Drop it down, its corresponding angle is also equal. So here you can see in this type of setup, we actually only have 2 angle measurements. So if I were to give you an example of some measurements here, and we said that angle 1 was 100 degrees, we can actually figure out the rest of these angle measurements. Angle 4 would also be 100. Angle 5 would also be 100. Angle 8 would be 100. Now to figure out the red marked angles, these are linear pairs when they're next to each other. So I would take 180 and subtract off 100 to get 80 left over for angle 2, which is also the size of angle 3, angle 6, and angle 7. All right, let's give that a try here. Solving for the unknown variables. So doing that same process, we want to make sure that we figure out, based on this 35, which angles are congruent and which angles are supplementary. So take a moment to try to figure out the measurements for A through G. All right, this is how we do it. So on this one, we've got 35, a vertical angle to C. So C is also 35 degrees. When I have corresponding angles, that's when I slide these 2 parallel lines together, kind of smash them together. So the 35 would land here for angle D and here for angle G. Now with supplementary or linear pairs, like I have here, angle A would be found by taking 180, subtracting off, the 35 to get 145 remaining for angle A. Because of vertical angles, B would also be 145. Because of alternate interior angles, B's measurement can transfer to E. And because of alternate exterior angles, A's measurement can transfer to F. Now, I had mentioned some other ways of finding it here, but really it's all the corresponding angles that match up. So again, we have 145, 145, 35, 35, 145, 145, and 35. All right, next it says, write a deductive argument explaining why alternate interior angles is true, but we get to assume that the vertical angle conjecture and corresponding angles is true. Use the diagram to explain. So first I want to figure out what are my alternate interior angles, and I'm going to abbreviate that AIA so I don't have to write out the whole thing. Those alternate interior angles would be something like 3 and 2. They are on opposite sides of the transversal, and they are inside the parallel lines. So this would be angle 3 and angle 2. Now, we need to prove that those two are the same size using the fact that we have vertical angles that are the same size. So here I'm looking for a pair of vertical angles that would be the same size. That would be angle 3 and angle 1. So angle 1 is equal to angle 3 because they are vertical angles. The next part said we can assume that corresponding angles are congruent. So looking at this diagram, which two angles are in the same position? And that would be angle 1 and angle 2. So angle 1 is congruent to angle 2 because they are corresponding. Now, if I look at those two pieces of information, they both have angle 1 marked the same here. And if both angle 3 and angle 2 are the same size as angle 1, then angle 3 must be equal to angle 2. All right, and what we have left is our summary, which we will use that to recap the information tomorrow.